Hey Algebra 2, it's been a while since we've done a video, but I am back. We are ready to roll. And as usual, you're going to take notes on this, whether you take them on the doc that I've provided you or you want to write them in your own notebook or whatever. I don't care, as long as you're taking some notes. And I encourage you to pause the video to try the problems before I do them out. Maybe watch like the first two and then do the next one on your own and see if you're getting the hang of the strategy here. So in this video, we're going to talk about factoring part 5. Parts 1 through 4 were GCF, difference of squares, FOTAT, and factor by grouping. Here we have factoring a trinomial when A is not 1, otherwise known as what we're going to call the AC method. So that's a lot of abbreviations, but we're going to be masters at this. We're going to get them all down. The AC method is really special. It helps us with a lot of factoring. But before we do that, let's recap what we know about factoring trinomials in general. So basically, all we really know so far is when we have a trinomial with A equal to 1, so that would look like x squared plus bx plus c. We use FOTAT to factor it. Right, so that stands for factors of our C term or our constant that add to, that's the tat, the middle term B. Right, and then we also know that sometimes we have to factor a GCF out to get to this point. Right, and we know that this is going to turn into, it's going to be equivalent to factored form, right? So we're going to start with, x squared plus bx plus c, and we're going to end up with factored form, which is going to be GCF if there is one, times x, and then it's going to be like plus or minus, like not both, but one of the signs, one of the factors, and then x plus or minus whatever the other factor is, right? So that's what we come up with in our FOTAT process, right? So if I did my factors of C that add to B, we would want like F1 times F2 and F1 plus F2. Whatever I get there ends up in my factors. And the sign is just directly related to whatever the factor is. If it's -2, then it's x minus 2. If it's +3, it's x plus 3. So that's what we know about trinomials and factoring trinomials so far, which is not much. We really are just comfortable with A equal to 1. If A is not 1, there's typically a GCF. But what we need to consider is what's going to happen when we're given a trinomial and A is not 1 and there's no GCF, or sometimes there's going to be a GCF, but that GCF still leaves us with A not equal to 1. So that really means that we're going to have an A term. For example, we're going to have something like 3x squared plus 5x plus 6. I don't even know if that factors. I don't think it does, but that doesn't matter. But what I'm getting at here is I'm looking at this expression and there's no GCF and A is 3. So what do I do? How do I factor that? That's where the AC method is going to come in handy. And the AC method basically means combining FOTAT and factor by grouping with a few additional steps along the way. So I'm going to write out the steps first, and they're going to seem maybe a little confusing. I hope not, but they might be. And then we're going to apply those steps to some examples to hopefully clear it up for you. So steps to factoring a trinomial when A doesn't equal 1, aka using the AC method. And there is a reason why it is called the AC method, and you'll see in a second. So remember, we want to keep in mind that now we're factoring ax squared plus bx plus c. right? So there's no longer just x squared, it's ax squared. So there's some number other than 1 in front of our x squared, and I can't factor it out. We are still going to look for a GCF first. That's always really important to us. Got to consider first greatest common factor, right? So look to factor out a GCF if necessary. That'll make the problem a little bit easier for us because sometimes there is that GCF and then I'm not even going to need to do AC. I'm just going to do FOTAT. So look for that GCF. You can simplify the problem. Don't force a GCF, right? So if it's not divisible by that number, don't force it. The second thing we're going to do now, and this is why it's called the AC method. Once you factor out that GCF, you're still going to be left with an A term, hopefully. Well, not hopefully. If you aren't, you just use FOTAT. But if you still have an A term, what you're going to do is you're going to multiply A times C. Hence, AC method, right? So that just means multiply the value in front of x squared with the constant, the last term. Right, so we multiply AC. And this is where what we know comes in. So now we're going to use FOTAT, but we're just going to tweak it just a little bit. So step 3 is going to be apply FOTAT. But now we're looking for factors of AC. So before it used to just be factors of C, now it's factors of AC. So that number you got in step 2. So factors of AC, and then we still want those factors to add to B. So really the only new part here is that I'm thinking of factors of AC instead of just C. So apply FOTAT, factors of AC that add to B, right? So really that's going to look something, I'm going to squeeze in a little table here, right? Factors of AC that add to B. And we're just going to list them out like we normally do. Once we get those factors, again, it's going to look a little different. We don't just go straight to factored form, right? Normally with FOTAT, we get our factors and we go straight to factored form. Here, with the AC method, what we're going to do, once we have those factors, we're going to use the two factors to split the middle term. So basically what that means is you're going from ax squared plus bx plus c to ax squared plus factor 1 times x plus factor 2 times x plus c. So you're creating a 4-term expression. And I think this will make a lot more sense with an example. But basically, this is what we want to have. Because once we have 4 terms, we can use factor by grouping. So step 5 is apply factor by grouping to the 4-term expression, which we're solid at. We know how to factor by grouping. So it's just this like steps 2 through 4 that are new, but they're not even that new. We've kind of put all the pieces, we're just putting all our pieces together. So we're gonna apply factor by grouping to the 4-term expression to get our answer. So this type of factoring does require the most work, but the more practice you do, the better you get at it. And that was the whole point of teaching FOTAT and factor by grouping first, is so that when we got here, it was like, oh, I already have these skills. This is not brand new. I can do this. And you can. So those are our steps. Let's put them into action. So we've got a bunch of examples here. Like I said, maybe watch me do the first one and then pause and try to do the second one and kind of go from there. So first things first, I'm going to look at my expression. 2x squared plus 7x minus 15. I notice there is no GCF and A is not 1. A is 2. So this means I'm going to use AC method. Can't use FOTAT, A is not 1, and no GCF. So I'm jumping right to AC method. So what that means I'm going to do is I'm going to multiply A times C. A is 2. C is negative 15. So 2 times negative 15 is negative 30. So now I apply FOTAT. Factors of negative 30, right? Factors of AC that add to what's B? B is 7. So factors of negative 30 that add to 7. So let's work this out. Two numbers that multiply to 30, or sorry, negative 30, 1 and negative 30, that's not going to work. 2 and 15, that doesn't work. How about 3 and 10? So negative 3 and positive 10. If I add those, negative 3 plus 10, they do add to 7. So those are our winners. Now this is where it's different. Previously, we'd just go x minus 3, x plus 10, and we call it a day. We can't do that now. What we're going to do is we're going to take those numbers and we're going to split this b term. And it doesn't matter which one you put where. This comes down, my x squared term comes down, and so does my c term. Those don't change. But now instead of 7x, I'm going to replace it with negative 3x and positive 10x. And you should notice if you combine those like terms, you get back up to 7. So these are equivalent expressions. I'm just expanding it out to get 4 terms. Now that I have 4 terms, also please notice I have my signs, negative, positive. Also notice the b term has an x, so each of these terms have an x. You need to be able to the whole point is if you were to combine like terms, you'd get back to where you started. I don't want to combine like terms because that wouldn't help me. That defeats the whole purpose. But now I've got 4 terms, so I'm going to factor by grouping. And at this point, you should be comfortable. The greatest common factor of 2x squared minus 3x is x, leaving me with 2x minus 3. And the greatest common factor of 10x and negative 15 is positive 5, leaving me with 2x minus 3. I know I'm right because I see the same binomial twice, right? We know that from factor by grouping, same binomial twice means I did this right. It's my greatest common factor binomial. So my final answer is going to be 2x minus 3 times the leftover, x plus 5. So I have equivalent statements. I started with 2x squared plus 7x minus 15, and through this factoring, I found out that that's the same as 2x minus 3 times x plus 5. Standard form versus factored form. And you can check my work by distributing out the side that is factored and see if you get the same thing, but you definitely should. So that is AC method in a nutshell. Like I said, I encourage you to pause the video and work through some of these and then click play and go from there. So for B, I keep like clicking up there to get my pens and I forget that I have them favorited over here. Sorry guys. So for B, I'm going to look here, 7x squared plus 29x plus 4, no GCF. So I am going to go to AC because A is 7, not 1. So I'm going to do A times C, which is 7 times 4, because C is 4. So 7 times 4 is 28. So I'm going to think of factors of 28 that add to 29. Well, two numbers that multiply to 28 that add to 29 seems pretty simple. Going to be 1 times 28. So now I split my middle term. 7x squared plus x, or plus 1x, plus 28x plus 4. Does not matter where you put which one. If I did 7x squared plus 28x, I'd still end up with the same answer. Apply factor by grouping. GCF here is x, so 7x plus 1. Greatest common factor on this side is positive 4. GCF 7x plus 1. I know I did it right because I see the same binomial twice. So final answer 7x plus 1, x plus 4. That is factored form. These are equivalent statements. I started here with standard form, and I just found out that that is the same as 7x plus 1 times x plus 4. Example 3, look for a greatest common factor. There is no GCF between 3x squared, 17x, and 20. A is not equal to 1, so we're going to do AC. A is 3, and C is positive 20. That's going to get us to 60. So now we say factors of 60 that add to negative 17. Two numbers that multiply to 60, could do 1 and 60. I can do 2 and 30. That won't work. But what if I do 3 times 20? If I add those, I get, oops, I'm multiplying again. 23. I don't know, I just had like a brain fart, guys. So that's not good. I want positive 60. Two negatives would get me negative 23. Let's see. Some other options. 4 times 15. If I add those, you don't get 17. I know I want negative 17, but I'm just trying to work through this a little bit. Let's see. Divided by 5. Well, that might work. So if I do 5 times 12, I get 60. And if I do 5 plus 12, I get positive 17. But I want negative 17. So I'm going to make this -5 and -12. Still multiplies to 60. And now I've got -17. So again, those are my factors. Split the middle. Right, I'm splitting up this middle term with 5x and -12x, bringing down what I started with so I don't lose the 20 or the 3x squared. And again, I could have switched up this order. I could have wrote the 12x and then the -5x. It really doesn't matter. Split the middle, factor by grouping. So I'm going to say the GCF here is x, left with 3x minus 5. The greatest common factor here is -4. Left with 3x minus 5. I know I did it right because I have the same binomial. So my answer, 3x minus 5 times x minus 4. Again, it's important to know that these are equivalent. Same expression, just a different way of expressing it. D. Gotta look for my dear friend greatest common factor, 4x squared plus 20x plus 16. There is a GCF. There is a GCF of 4. I'm going to take that GCF out and I'm going to be left with 4 times the quantity x squared plus 5x plus 4. Now hold up. A equals 1 now, right? There's a 1 in front of my x squared. I can use FOTAT. I don't need to use AC. I don't need to split the middle. You could, but it's unnecessary. So I'm just going to go factors of 4 that add to 5. Nice and easy, 1 times 4. So I don't need to split the middle because A is 1. Nice and easy. So this one wasn't even AC. I didn't need to make it into 4 terms because it works with FOTAT. A was 1. So that's why it's important to factor out that GCF. It can be really helpful and make a problem much faster. Problem E, no GCF, A is not 1, A is 12. So we've got AC is 12 times -15. -180. Yikes. Factors of -180 that add to 57. So they're probably going to be bigger numbers. So I just start like dividing in my calculator until I find some numbers that might seem good. Let's see. -181, -18 times 10 wouldn't work. Right, so it's possible it's not factorable. I'm not saying it's not, I just can't think of the factors off the top of my head. Let me see. Oh, because I'm a dope. Guys, I didn't realize that there's a GCF here. Making my life a lot harder. You know, it's that 57 that always messes me up. I always forget that 57 is divisible by 3. GCF 3. Oh, this is going to make this problem so much easier. Watch this. 3 times 4x squared plus 57 divided by 3 is that pesky 19. Now my numbers are much smaller, but here's the thing. Before, in problem D, when I took out the GCF, I could just use FOTAT. This time, I can't because my A is still not 1. Now my A is 4. So we're going to do A times C. We're going to do 4 times -5. The sign matters. It's negative. That's -20. Oh, wow, guys, look at this. Factors of -20 that add to 19. Bless, way easier than -180. How about 20 and -1? Nailed it. Split my middle term. So I've got my GCF on the outside, don't forget it, times my 4x squared, and then I'm going to do plus 20x minus x minus 5, because I've taken these factors, 20 and -1, and I have split my middle term with them. Now I've got my 4 terms, factor by grouping, GCF on the outside. GCF of the left side is 4x, left over with x plus 5. GCF of the right side, -1, left over with x plus 5. Final answer, completely factored, 3 times x plus 5 times 4x minus 1. It still would have worked before, but it would have taken us a really long time to find factors of -180 that added to +57, and just who wants to do that? Last one, if you haven't tried any on your own, I really encourage you to give this one a shot and see how far you can get. I will give you a hint, there is a GCF, it is 2. So I've got a greatest common factor of 2. I can factor that out. I'm going to be left with 3x squared minus 5x plus 4. And A is still not 1. So we're going to use AC. I'm going to find A times C to be 3 times 4, 12. So I want factors of 12 that add to -5. Numbers that multiply to positive 12. 1 times 12, that won't work. 2 times 6, that won't work. 3 times 4, that won't work. Let's try to throw some negatives in there. -1, -12, still doesn't work. -2, -6, still doesn't work. And then if I do -3 and -4, that's not going to work either. This cannot be factored any further. This is the furthest it can be factored. That trinomial is not factorable. So don't force it. Oops. Right? It's okay. Not every single polynomial can be factored. That's just life, and we'll understand that soon. Again, I will explain the context of factoring and why we do it shortly, but we really need to get the skill down before we can get there. So that's the straightforward examples. I have a couple of more examples that kind of take a different twist on factoring, but that is the skill of factoring with AC method in a nutshell. I really encourage you to pause the video and try this one. It says use factoring techniques, so use your AC method. Don't just go ahead and distribute the answer choices. I want you to factor. I want you to practice the factoring. So which is equivalent to negative 6x squared plus x plus 2? No GCF. In this, there's no GCF. A is not 1, so we're going to do the AC method. Negative 6. Oh, actually, hold up. Again, guys, I'm being so silly today. The GCF is negative 1. We don't like when our first term is negative. Blah, gross. So we've got negative 1 as our GCF. So I'm going to take that out. And I'm going to be left with 6x squared minus x minus 2. Now I can use AC. I'm going to do 6 times negative 2 and get negative 12. So we want factors of negative 12 that add to negative 1. And we're going to get, how about negative 4 times 3? So I have negative 1 on the outside because that's my GCF, times my 6x squared didn't change. My minus 2 is not going to change. What's going to change is I'm going to split my middle to be negative 4x plus 3x. Apply your factor by grouping. Bring down your GCF always. That's my left side. Here's my right side. Final answer, negative 1 times 3x minus 2 times 2x plus 1. So if I look at my answer choices, I can cross off choice A and choice B because they're not even close to what I have. And then if I look at choice C, it's really close, but the signs are not right. So it leaves me with my only possible answer to be choice D. So that covers our fifth type of factoring, which again is factoring a trinomial where A is not equal to 1, A is not equal to 1, and we call it the AC method. If you have any questions, please ask them next class. I'd be happy to answer them before we go on and do more practice of these problems.